This question here, which focuses on equations of a straight line, is the Higher 2019 Paper 1, Question 7. Now what this question wants us to do is find the equation of a line perpendicular to L, where all the information we've been given about L is what the angle is, and we know this point here from the second line. Now we know that L makes an angle of 30 degrees with the positive direction of the x-axis. So if we were to visualize that and look, you could imagine us taking this and drawing the line L, just generically like that. What that tells me is this angle in here is 30 degrees. Now there's two variations, remember, of us finding the gradient of a line, one part that we definitely need. So we can either do y2 minus y1 over x2 minus x1, or we know that the gradient m is equal to tan theta, where theta is the positive directional angle here. Now because we don't have 2 points, we can't do this variation here. So we have to use the angle. So we know for this one we're going to use this variation. What we could say then is that m equals tan 30. Now, one thing you'll have to note is, remember, this is a paper 1 question, so you're going to have to be able to do tan 30 yourself. But this is one of the exact values you should know. You should be able to memorize and recall the triangles associated with it. So if it helps, draw it. So you've got your little right angle triangle here, where we can work out the angles of 30 and 60 degrees. And in this one, the line opposite the 30 is 1, the line opposite the 60 is root 3, and the hypotenuse is 2. And if we use SOHCAHTOA, we're at tan 30 here, so tan is opposite over adjacent, so 1 over root 3, so this gradient here is given by 1 over root 3. We then have the gradient, but we have the gradient for this line. Remember, what we want is the gradient of the line perpendicular to this line, so the line that goes off that way in a 90-degree angle. If we've got two lines like that, and we know the gradients of them, so m1 and m2, and they're perpendicular to one another, we know the relationship m1 times m2 equals -1 exists. So using that in this information here, I can say that 1 over root 3 times m2 is equal to -1. So my second gradient, the gradient of the line that we want, is given by taking the root 3 up, and it would be -√3. So there we go, I've got the gradient. Remember, for a straight line, we want y equals mx plus c. We need all these parts, so we need the gradient m. I now need the y-intercept, but I'm told in the question it cuts at 0, -4. So -4 is my y-intercept, so I know my c. So because of that, I can quite simply write down the equation of my line. Y equals -√3 x minus 4. There you go, job done. Equation of my straight line which is perpendicular to that line, L. This kind of question here, 4-mark question this was. First mark came from knowing that we had to do m equals tan 30. Second mark was for recalling this triangle and getting the exact value of it, so 1 over root 3. Third mark came from using this property here and getting the -√3 as the gradient. And then your final mark came for using the rest of the information and getting the full equation of the straight line written down. We have to remember these properties, so particularly things like m1 times m2 is -1, and the two variations of calculating our gradient, particularly at this level. They all come in very handy and very useful for us to work with.